Hello students, myself Mrs. Pallavi Borade, teacher at Fergusson Junior College, Pune. In the previous lecture, we have seen the first chapter of Vocational Electronics Paper 1 subject, that is instrument. In that chapter, we have seen the introductory part of the instrument chapter. In that, we have studied the introduction to CRO, then the first part of the CRO, that is CRT, the detailed study of CRT. Then we have seen the systems which are used in CRT. The first system is focusing system and system. So today we are going to start the second remaining part of this chapter. Till now we have seen the CRT part. So this is the internal view of CRO. If you observe this picture, we have at the left side we have CRT and the remaining part is the circuitry which is used to operate this CRT. So let's start with the block diagram of CRO. So whenever we talk about CRO, CRT is the main basic part, and along with this CRT we have 7 blocks which is circuitry which is used to operate the CRT. So these blocks are, first is Y input, then we have vertical attenuator. After that, vertical amplifier. The output of this amplifier is connected to delay line, and that delay line is connected to the vertical plates. In the horizontal section, we have trigger circuit. So whatever the output of attenuator is connected to this trigger circuit. Then this trigger circuit output is connected to the time-based generator. After that time-based generator, the output of this TBG is connected to the internal external switch, and that switch is also connected to the horizontal amplifier. So this amplifier is connected to horizontal plates inside the CRT. In between this time-based generator and the CRT, we have blanking circuit, and it is connected to the control grid inside the CRT. So let's start the detailed function of each block. The first block, that is Y input. So it is the main input of CRO to which the input signal is connected. The waveform of this input signal is displayed on the screen of the CRT. So basically whatever the external signal which is applied by using the connectors, it is connected to the Y input. Then that input is connected to the vertical attenuator. It consists of RC voltage divider which is marked on the CRO front panel as volt per division knob. So whatever the front panel control marked as volt per division, internally it is connected to the vertical attenuator. So this attenuator is basically attenuates the signal. We can control the Y input signal by using this block. Next is vertical amplifier. So it is a set of pre-amplifier and main amplifier. So the input of an attenuator sets up the gain of the vertical amplifier. So basically this amplifier is used to set the gain of the applied signal. After that we have delay line. So basically the delay line delays the striking of the electron beam on the screen. It will synchronize the arrival of the beam on screen when time-based generated signal starts sweeping the beam horizontally. Basically this delay line is used to delay between vertical input and horizontal input. So whenever horizontal input is coming to that horizontal plates, vertical input is already there. So to synchronize these inputs, we have, so this delay line is basically used to delay between two inputs. So about 0.25 microsecond delay line produces the propagation delay. So whenever we talk about general CRO, around 0.25 microsecond delay is there in between vertical input and horizontal input. After that, in the horizontal section, we have trigger circuits. So it takes the sample of input voltage connected at Y input of CRO, and it fits to the input of time-based generator. So the time-based generator starts only when input signal is present at Y input. So basically it will take a sample of the attenuator and it will start the time-based generator circuit. After that we have time-based generator. So it produces a sawtooth waveform. The waveform is used to sweep, or you can say the move, the electron beam horizontally on the screen. Thus, the sawtooth wave controls the horizontal deflection of electron beam along x-axis. So that's why this block is very important in the CRO, because it will produce horizontal signal, or you can say the horizontal move for this electron beam. So by using this block, we can move our electron beams horizontally. Then we have horizontal amplifier. It amplifies the sawtooth waveform coming from the TBG, that is time-based generator. It contains phase inverter circuit also. Due to this circuit, two outputs are produced. One output produces positive going sawtooth and other output produces negative going sawtooth. The first output is connected to the right side of H plate, that is horizontal plate, and the second output is connected to the left side of horizontal plate, so that the electron beam moves properly from left to right of the screen horizontally. So basically this amplifier amplifies the signal as well as it will produce two types of sawtooth waveform. Then we have blanking circuit. So basically this circuit is necessary to eliminate the retrace, which is produced by TBG and horizontal amplifier, which would produce when the spot on the screen moves from right to left. So basically the electron beam moves from right to left as well as left to right, and this retrace can produce confusion between the original waveform and the retrace. So when the electron beam reaches right end of the screen, the negative blanking voltage is produced by time-based generator and it is fed to the control grid of CRT to stop the electron beam. So it will remove the retrace which is produced by the horizontal amplifier. That's why this blanking circuit is also important in the CRO. Then we have one switch which is called internal external switch. A switch known as internal external is also connected after the output of TBG, that is time based generator. So when the switch is in internal position, that is INT position, the output of TBG, time based generator, is connected to the horizontal plates through horizontal amplifier. So whenever this position of this switch is internal, then whatever the output is of TBG is internally connected to the horizontal plates. But when this switch is connected to the external position, that is AXT position, internal sawtooth is cut off and some external signal can be connected to the horizontal plates. So we can apply external horizontal signal to this horizontal amplifier by using this switch. So in that case, we have to connect this switch to external position. And the last block is high voltage and low voltage power supply. So basically in CRO, we required high voltage as well as low voltage. So the high voltage section is used to power the electrodes of the CRT and the low voltage section is used to power the electronic circuit of the CRO. So high voltage supply is used to supply the powers for the CRT and low voltage supply is used to supply the voltage for remaining electronic circuits. So let's start with the time-based generator. As I said, this block is very important in the CRO because there is requirement for horizontal sweeping, and by using this block we can sweep our electron beam horizontally. So basically inside that block we have this type of circuit. This is the circuit diagram of time-based generator and the output waveform is sawtooth waveform. The output of this circuit is generally sawtooth waveform. Basically the UJT is used to produce this waveform. So this circuit is also called as UJT as a relaxation oscillator. So this will produce a sawtooth waveform and this type of circuit is called as oscillator. So how this circuit works? So if you consider this circuit, there is one UJT, there are two terminals B1 and B2 are the base and emitter is connected to that capacitor. In that circuit we have one variable resistor, that is R, and one positive power supply, that is VBB, is connected to that base 2 of the UJT. So basically the output of this circuit is across capacitor. So that sawtooth waveform is basically the charging and discharging output of the capacitor. So by using this UJT we can charge and discharge the capacitor exponentially and we will get the sawtooth waveform. When power is applied to that capacitor C, it charges exponentially through resistor R and the emitter voltage of UJT increases and UJT will turn on. And when UJT turns on, capacitor discharges through UJT as it provides low resistance between E and B and the value of VE decreases to VE min. At this value UJT will turn off. So it will act as a switch. For one case it is in switch on mode and in another case it will switch off. So by using this switching action, we will produce the charging and discharging process of capacitor, and we will get the sawtooth waveform across the capacitor, and hence this cycle produces a sawtooth waveform. Necessity of time-based signal. Why this time-based signal is required in the CRO? So basically the CRO usually displays the vertical input waveform as a function of time. So basically whatever the applied signal, it is in terms of vertical input. So this requires a horizontal deflection voltage that sweeps the CRT spots across the screen from left to right with a constant velocity. So if this time-based signal or X input signal is not present in the CRT, the electron can move only vertically, then we will get only vertical spot on the screen. So there is only movement of vertical section because of this TBG. If the TBG is not there, we will get only vertical spot. So to move those electron beams horizontally, we will require this time-based signal. That's why those time-based generator circuits are very important in the CRO. After that, how CRO displays a waveform on the screen. So basically, this is the combined effect of horizontal plates and vertical plates voltages. Okay, so if you observe this picture, we will see there is one sinusoidal waveform which is displayed on the screen, and at the horizontal section we have sawtooth waveform. So basically the waveform which is displayed on the screen is the simultaneous effect of vertical section and the horizontal section, that is time-based generator output. So to observe waveform on a CRO, the waveform of voltage under test is applied to Y plates, and voltage obtained from a sawtooth generator is applied to the X plate. So when both horizontal sawtooth voltage and input voltage is applied to the vertical deflection Y plates, the beam is under the influence of two forces, and the forces are one in the horizontal direction, moving the beam at a linear rate from left to right, and in the vertical direction, moving the beam up and down. So the first force is by TBG circuits by using that sawtooth waveform, and the second force by using the vertical direction. So the X plate voltage is proportional to the horizontal movement, and the vertical deflection proportional to the voltage applied to the Y plates. Thus the beam moves up and down according to the magnitude of the inputs. So hence we will get the simultaneously effect of horizontal and vertical direction on the screen. So till now we have studied the block diagram of CRO. So there are types of CRO which are usually available in the market. So there are special types of CROs are available. The first one is dual trace CRO. So in this type of CRO, two vertical inputs are connected. So we have two trace in this type of CRO. After that, there is one special CRO which is called dual beam CRO. So generally in this CRO, the electron beam splitted into two parts. Then we will get two beams on the screen. Then we have storage CRO. In this CRO, observations can be stored. So you can easily store your readings of your CRO in this storage CRO. So some memory chips are used to store these observations. Then we have sampling CRO. So it is used to examine very fast signal. So if you apply very fast signal, then we can use this CRO for observations. After that, we have digital readout CRO. So basically this type of CROs, on the screen, observations are displayed in the digital form. So directly you can read your observation on the screen. There is no need to calculate any amplitude or frequency. So this is the picture of actual CRO which is used in our electronics laboratory. So from this we will study the front panel controls of CRO. So to understand the front panel controls of the CRO, from this picture you will understand that there are n number of controls which are used in CROs. So let's start with the front panel controls of the CRO, the function of each panel control. So the first control is the power on. So this is very basic control. It is used to switches the main supply on or off. So this is basically on off switch which is used to power on or power off. Next control is intensity. So it will control the brightness of the display by varying the voltage of control grid. So basically this control is internally connected to the control grid. So if you change the negative potential of control grid, it will change the intensity of electron beam on the screen. Then we have focus. So basically this control is used to control the sharpness of the display by varying the positive voltage of focusing anode. As we know, this focus control is internally connected to the focusing anode, and if you change the voltage of focusing anode, it will give the change in sharpness of the display. Then we have time per division, or you can say time base. So this switch or this control is used to control the rate of rise of time base signal by changing C, that is capacitor, in the time base generator. So it will change the time base signal and it will automatically change the rise of the time of this capacitor. Then we have variable, that is VAR. It is used in calibration position, the selected sweep speed, and the continuous control of frequency by varying R. Next we have horizontal position control, or multiplied by 5. So it controls the horizontal position of the display, and when X5 is pulled, it increases the sweep 5 times. So it is multiplied with by 5. Then we have level, the variable control selects the trigger point on the displayed waveform. You can level the input signal by using this control. Then we have auto or norm. In auto mode, trace is displayed in absence of any input signal. So you have to press norm condition for normal inputs. Then we have line. Line is used to triggers from power line frequency. So we can display the power line frequency on the CRO with the help of this control. Then we have TV control, that is triggers from low frequency component of TV signal. So by using this control, you can display TV signals also on the screen. Then again we have int and ext position. As I said, this internal mode displays the triggers from the signal derived from channel 1 and channel 2 or line. And in the external mode, triggering from any other external source is fed through external trigger BNC socket. So in this position, in this control, we have internal position, then we can apply internal signal to the screen, and in the external position we can apply external signal by using external triggering BNC socket. Then we have plus or minus control. It selects triggers point on positive or negative slope of the displayed waveform. Then we have channel 1 or channel 2. So these controls are basically used in dual trace CRO. Select trigger signal from either channel 1 or channel 2 inputs. Then AC or DC. So select trigger signal coupling from AC. A capacitor is connected in series with input. So whenever you applied AC signal, you have to press AC control, and when we apply DC signal to the CRO, then we have to press DC control. Then SWP, that is swap, XY. When pressed, converts channel 2 input into the X channel and enable use as an XY mode. So this control is basically used for swapping. Then we have 0.2 volt and 1 kilohertz frequency control is there. So basically this is used for calibration signal. We have 0.2 volt and 1 kilohertz square wave calibration signal. Internally it is connected in the CRO. Then we have position or X5, controls vertical position of the display, and X5 pulled vertical sensitivity, it is increased for 5 times. So this control is used for vertical position. Then we have ground, selects input coupling or ground. Then we have input BNC, that is the connection where we connect our applied signal. So input terminal, you can say, to channel 1 or channel 2. If 2 channels are used, then we have 2 input BNC. Then we have trace, screwdriver controls to adjust the horizontal tilt of this trace. So by using this control, you can adjust your horizontal tilt of the trace. If there is any tilt in the horizontal signal, you can adjust by using screwdriver. Then we have volt per division. So basically this is internally connected to the vertical attenuator, and you can adjust the amplitude of the signal by using this control. Attenuator from millivolt division to volt per division. So this is the range of this control. Then we have some vertical modes. In that, the sub modes are alt and chop. So it will select switching mode for 2 channels in dual CRO. Then we have dual or mono. So in dual operates as dual trace CRO. In mono mode, we can select only one trace. Third one is channel addition, that is channel 1 plus channel 2, and signals of both channels are added. So if you press channel 1 and channel 2 control, then the signal of channel 1 and channel 2 will add. Fourth one is channel subtraction, that is channel 1 minus channel 2. So basically in this control, channel 2 signal is algebraically subtracted from channel 2. Then fifth one is channel 2 inverted, that is CH2-INV. Polarity of channel 2 is inverted. So when we want to invert our channel 2 signal, then we can press this control. Then let's start with the applications of CRO. So where we can use this CRO for measurements. The first application of CRO is AC voltage measurement, or you can say this measurement is basically amplitude measurement. So what is this amplitude measurement? So CRO indicates peak to peak value of voltage, and when we apply AC voltage is applied to the vertical input of CRO, volt per division knob is used to adjust the vertical signal. So whenever we measure amplitude, that is V peak to peak value of the signal, then we have to calculate V peak to peak as number of vertical division on y-axis multiply with volt per division knob scale. The final value of this product, you will get V peak to peak value as in terms of amplitude measurement. And if you divide it by 2, you will get the amplitude as in terms of Vp. So this is the basically amplitude measurement of CRO, and the unit of this amplitude measurement is volt, because amplitude is always measured in volt. Second application is DC voltage measurement. So to obtain horizontal reference line exactly on the x-axis when DC voltage is not applied, and if you apply DC voltage to the vertical input, the horizontal line either moves up or down, indicate that input voltage is positive or negative. So whenever you apply DC voltage to the horizontal line, it will show the reference line on the screen. Then when we apply DC voltage, it will shift upwards or downwards, indicating that input voltage is positive. If it is positive, then it will move up, and if it is not negative, it will move down. So easily you can calculate the DC voltage by using number of vertical divisions which are shifted towards positive or negative and into volt per division knob scale. So in this way you can calculate the DC voltage. Again, it is measured in volt. The third application is time period measurement. So basically time period is required to measure the frequency, that is capital T, and it is measured in seconds. So apply the input signal to Y input and adjust time per division knob so that 1 or 2 cycles of input signals are seen on the screen, and you have to take 2 readings, number of division on x-axis by using that cycle and into time per division scale. So product of these 2 readings, you will get the time period, that is capital T, and it is measured in seconds. The fourth application is frequency measurement. So there are 2 methods which are used by CRO. The first method is time-based signal internally. By using this internal time-based, first of all you have to calculate the time period, and then you have to calculate the frequency. So this is the first method. So whenever you apply unknown frequency signal to input of CRO, adjust time per division knob so that 1 or 2 cycles of input signal are seen on the screen. Then you can calculate T as time period, again number of division on x-axis, count those divisions into time per division scale. So you will get time period in seconds. Then by using this time period, you can calculate the frequency F, capital F, as F is equal to reciprocal of time period, that is 1 over T, and it is measured in hertz. Let's see one example for this. If number of division on x-axis are 4, that is 20 divisions are there into 0.2, and time per division scale is at 1 millisecond, then calculate the frequency. So if you see the solution, then we have time period capital T is equal to 4 into 1 millisecond, because the divisions are 4 and the time division scale is 1 millisecond. The product of this is 4 into 1, that is 4 millisecond. So converted into seconds, that is 4 into 10 raised to minus 3 seconds. So The final t is 0.004 seconds, and you have to calculate the frequency. So if you put this value in the formula f is equal to 1 over t, then you will get 250 hertz as your answer of frequency. So the frequency for this example is 250 hertz. So in this way you can calculate the frequency using internal time base. The second method is using Lissajous figure. So this method is basically to calculate the unknown frequency which is applied to the CRO. A known standard frequency signal is applied to the horizontal input, and the unknown frequency signal is applied to the vertical input of CRO. Then patterns called as Lissajous figures are obtained on the screen. Unknown frequency is calculated by using this following formula. Fy, that is unknown frequency, is equal to number of loops cut by horizontal line divided by number of loops cut by vertical line into f standard frequency. So standard frequency is basically the given frequency. By using that Lissajous figure, you can calculate the loops and you can easily calculate the unknown frequency which is applied to the vertical input. So if there are different types of Lissajous figures which are obtained on the screen, if circle is there, if circle Lissajous figure is obtained on the screen, then unknown frequency is equal to the standard frequency. And if an ellipse is obtained on the screen, then there is some phase shift between these two frequencies. So let's see one example. Calculate the unknown frequency in the given Lissajous figure 1 if standard frequency is 1 kilohertz. So in this figure 1, we have one Lissajous figure. Okay, so 3 circles are there, and if you cut this horizontally and vertically, you will get number of loops cut by horizontal line and number of loops cut by vertical line, and f standard frequency is given as 1 kilohertz. So here number of loop cut by horizontal line is 1 and number of loop cut by vertical lines are 3. So if you put this value, then 1 by 3 into 1000 hertz, that is 1 kilohertz, is our given frequency. Then we will get the unknown frequency as 333.33 hertz. So in this way you can calculate the unknown frequency by using this Lissajous figure method. Next application is phase measurement. So by using this phase measurement, you can easily calculate the phase difference between two applied frequency. So basically whenever you measure phase between two signals, we have to apply two frequencies to the CRO, and if you will get some kind of Lissajous figures on the screen, and by using this formula, phase difference between the two signals can be calculated as sin theta is equal to A by B. So from this diagram you will see there are intercept between two sections on the x-axis and y-axis. So there is one A between the, you have to count number of divisions on the y-axis where your ellipses intercept, and B where peak points are of this ellipse are connected. So you will get A and B, and in this way if you take sine of theta as A by B, where theta is the phase angle, and you can easily calculate the theta as sine inverse of A by B ratio. So in this way you can calculate the phase measurement. Today we have seen the block diagram of CRO, the detailed explanation of each block of CRO. Then we have seen the important block, that is time-based generator of the CRO. Then necessity of time-based signal. Then we have seen the different types of CRO, front panel controls which are used in CRO. Then we have studied the applications of CRO. The CRO is used for different types of measurements, that is amplitude measurement. You can measure time period, you can measure frequency, you can measure phase. So in this way we have studied the applications of CRO. So in the next lecture we will study the remaining two instruments, that is function generator and DMM. Thank you.